It looks easy, right? So can you solve this geometry challenge? Here's the question. Given this figure, this angle right over here, let's call this alpha, and this angle is 2 alpha. Now, this segment right over here measures 6 units, and this segment is 5 units. Also, it's given that the length of this segment, this side, is 10 units. Now, the question is, what is the area of this green triangle? So, pause this video right now and see if you can answer this question, because I will show you the answer and the solutions in 3, 2, 1. Alright, the answer simply equal to 15 square units, and that is the answer to this question. This is the area of this green triangle. Now, of course, the question is, how do we get 15 square units? I will show you 2 different solutions to find the area of this green triangle. So the first one is using the cosine law. Now the second one is the Stewart theorem. So let's begin by using the cosine law. Before we use the cosine law, let's name some segments. So this segment, let's call this A, and this segment, let's call this as B. Now, don't assume unless stated. In this figure, we cannot say that this triangle, this blue triangle, is an isosceles triangle unless stated. So let's have A and B for the meantime. And now, before we use the cosine law, we need to have first the ratio of areas. And since we don't have the base and the height, we will use different technique to find the area of these triangles. And we will use this concept. So using 1/2 times the included side times sine of the included angle. In short, we can say that the area of this blue triangle simply equal to 1/2 times AB times sine of 2 alpha. And this green triangle simply equal to 1/2 times 10 times B times sine alpha. Now we can now use the ratio of areas. So we can say that the ratio of the areas of blue triangle to the green triangle simply equal to 6:5. Now, let's focus to this equation and let's substitute their given areas like this. Now, simplify. 1/2 cancel out, B cancel out, and this 10 and 5 cancel out. This remains 2. So we have A times sine of 2 alpha over 2 times sine alpha equals 6. And we can use some identity because sine 2 alpha is equivalent to 2 times sine alpha times cosine alpha. Now cancel some similar terms and we arrive at A times cosine alpha equals 6. And we can say that cosine alpha equals 6 over A. Now let's set aside this result. We will use this later on. And now we can now use the cosine law. So this length on the bottom part must be equal to 6 plus 5 or simply equal to 11. Now this is just plug and play. So using the cosine law, we have 11 squared equals A squared plus 10 squared minus 2 times A times 10 times cosine of 3 alpha. Now we need to simplify this equation and isolate cosine of 3 alpha. If we do that, we have cosine of 3 alpha equals A squared minus 21 all over 20 times A. Now, using these 2 results, we can now find the value of A. And how to do that? Take note that cosine of 3 alpha is equivalent to 4 times cosine cube alpha minus 3 times cosine of alpha. So this equation becomes this, and we know cosine of alpha is 6 over A. So we can substitute cosine of alpha with 6 over A like this. Now simplify this equation. This is just an algebra, and you arrive at A raised to the 4th power plus 339A squared minus 17,280 equals to 0. Now you can factor this out nicely as A squared minus 45 multiplied by A squared plus 384. And we don't care to the negative value of A or the imaginary value of A. We want a real value for A. In short, we get that A squared equals 45 and A equals 3 times square root of 5. And that is the value of A. Now, we know that cosine alpha is 6 over a, and a is 3 times square root of 5. In short, cosine alpha is 6 over 3 times square root of 5. Simplify, this becomes 2 times square root of 5 divided by 5. And now at this point, we now have the value of a. Now, how about the value of segment b? So let's use again the cosine law to this green triangle. And if we do that, we have 5 squared equals b squared plus 10 squared minus 2 times b times 10 times cosine of alpha. Now, we know the cosine of alpha is 2 times square root of 5 over 5. Now, plug in all the given values. We have 25 equals b squared plus 100 minus 20 times b times 2 times square root of 5 divided by 5. Simplify, and we arrive at this factored form, and we get two possible values for b. We have 3 times square root of 5 and 5 times square root of 5. Now, one thing is for sure, this b cannot be greater than 10. Now, approximately 3 times square root of 5 is 6.71, and 5 and 5 times square root of 5 and 5 times square root of 5 is 11.18. In short, b cannot be equal to 5 times square root of 5. So b is 3 times square root of 5. We now have the value of a and b. So a is 3 square root of 5, and also b is 3 times square root of 5. Now, this blue triangle is technically an isosceles triangle. Since this blue triangle is an isosceles triangle, we can now get the area of this green triangle. And we have two possible methods to find the area of this green triangle. The first one is by using this concept a while ago. So 1/2 times AB times sine of included angle. But since this is sine alpha, we need to get the value of sine alpha using this cosine alpha and using the Pythagorean identity. This is also possible, but there is an easiest way to find the area of this green triangle. If we find the height of this green triangle, then we're done because we have the base. Now, to find the height of this green triangle, we will use the fact that this blue triangle is an isosceles triangle. So from this point, let's drop a perpendicular bisector. And this base is cut into 2 equal parts, so these parts are both equal to 3 units. Now, to find the height, we use Pythagorean theorem. So we have h squared equals 3 times square root of 5 squared minus 3 squared. We get that h squared equals to 36, and we get that h equals 6. In short, the height of this triangle simply equal to 6 units. Now we have the base and the height, so we can now get the area of this green triangle. So we are using 1/2 times base times height. 1/2 times 5 times 6 simply equal to 1/2 times 30, or simply 15 square units. And that is our answer to this question. So using cosine law, we get that the area of this green triangle simply equal to 15 square units. Now, let's have our second solution using the Stewart theorem. But before we use the Stewart theorem, what we need is this concept, the angle bisector theorem. Now, take note, this is 2 alpha. So why not? Let's divide this into 2 equal angles. We have alpha and alpha. And again, suppose that we don't know that this blue triangle is an isosceles triangle, because don't assume unless stated. So let's call this segment be equal to x, and the other side simply equal to 6 minus x. And now from here, before we use the angle bisector theorem, let's name some important points. Let's call this point as A, this is B, this is C, this is D, and this is E. Now let's focus on this figure. Now focus on this triangle. And using the angle bisector theorem, we can say that AD over DE equals AB over BE. Now, segment DE is x, segment AB is 10, and BE is 5. In short, AD is equal to 2 times x. So we can say that this AD is 2x. And now, let's focus on this triangle ACE. So again, using angle bisector theorem, we can say that AC over CD equals AE over ED. Now, CD is 6 minus x, and ED is x. In short, AC over AE is 6 minus x over x. And now, from here, let's multiply the numerator and the denominator by the same constant, and that constant, let's call this as k. In short, we can say that AC is k times 6 minus x, and AE is k minus x, like this. Now, we can now use what we call the Stewart theorem. And in order to memorize this Stewart theorem very quick, you need to memorize the statement, man plus dad equals bomb plus sink. So using this Stewart theorem to our triangle, we can say that x times x plus 5 times 5 plus x plus 5 times kx raised to the power of 2 equals 10 squared times x plus 2x raised to the power of 2 times 5. This is just man plus dad equals Bob plus sink. Now simplify this equation, we arrive at this result, and we can say that k squared times x equals 15, or k squared equals 15 over x. Now, let's set aside this result. And let's focus on this triangle ACE. Again, let's use the Stewart theorem. Man plus dad equals bomb plus sink. Simplify this result, we arrive at this equation. Now, we know the value of k squared. K squared here is 15 over x. So we can substitute this 15 over x to this k squared, like this. Now, simplify, and we arrive at this quadratic equation in terms of x. We have x squared plus 7x minus 30 equals to 0. Factor this equation, we have x minus 3 and x plus 10. Now, we don't care to the negative value of x. In short, x cannot be equal to negative 10. Therefore, x simply equal to 3. Now, since x equals to 3 and k squared equals to 15 over 5, we can say that k squared equals to 15 over 3 or 5, and the value of k simply equal to square root of 5. Now, focus on our figure, and take note, we can say that all of this x must be equal to 3. Now, simplify. 2 times 3 is 6, and 6 minus 3 is 3. And the value of k is square root of 5. Now, from here, we can say that this blue triangle is an isosceles triangle. In short, this segment AD is a perpendicular bisector, or this creates a 90 degrees. Therefore, this is the height of this green triangle, and this is the base. So again, we get that the area of this green triangle simply equal to 1/2 times 5 times 6, or simply equal to 15 square units. And that is our answer to this question. So using two different methods, the cosine law and the Stewart theorem, we get that the area of this green triangle simply equal to 15 square units. And as always, we are done.